Okay, this is the pre-test for Unit 2, and these are the solutions. We're going to break the solutions into several different videos. So right now you're looking at the solutions to 1 through 4, and we're going to comment on basically Unit 2 deals with rational expressions, right? And by a rational expression, we mean nothing more than a fraction. Okay, so with fractions, the deal is this: um, you want to factor, and so that's just unit one, and then you want to look to cancel. Okay, in terms of rational expressions, so factor the numerator, factor the denominator, look to cancel. Pretty much the same deal in terms of multiplication of rational expressions. You factor each rational expression, and then numerator to denominator, you can cancel multiplied components. As far as division, we don't divide fractions. Instead, you take the divisor, you take the second fraction, you invert it and multiply. Um, and so it's really the same deal as the multiplication. You're going to factor numerator and denominator. You're going to flip the second fraction, factor the numerator and denominator, and then again look to cancel from one term to the other. Where rational expressions get a little more difficult is in adding them and subtracting them. You need to look for a common denominator. Oftentimes, the easiest way to find that common denominator is by factoring first and comparing. So, we're going to talk about multiplication, we're going to talk about division, we're going to talk about adding and subtracting rational expressions. But first, we're just going to talk about simplifying rational expressions. Um, so these first three exercises are simplifying, and then the last one is an addition of two rational expressions. So number one, we've got x minus 3 over x squared minus 9, and the x squared minus 9 should be clearly recognized as a difference of squares, and so you factor into the form x plus 3 times x minus 3. It's what we call a conjugate situation. And then from numerator to denominator, we're going to cancel the quantity x minus 3 with the quantity x minus 3. Now be mindful that when you do that canceling, there's a factor of 1 that's going to remain in that numerator. Oftentimes, we see students forget all about that 1 and respond with only an x plus 3, as if it's not even in a denominator. So you want to be mindful and be careful about that. So there's solution to number 1. Question 2, similar. Again, relies on unit 1 factoring. If you understood unit 1 factoring and the techniques involved there, then this one shouldn't impose much of a problem. X squared minus x minus 2, it's going to factor into x minus 2 times x plus 1 in some order. Doesn't necessarily have to be that order. And then again, the denominator is perfect minus perfect. That is perfect square minus perfect square. Factors into a conjugate pair of x plus 2 times x minus 2. Again, either order. Looking at the multiplication in the numerator, the multiplication in the denominator, the fact that division and multiplication undo one another, the x minus 2 and the x minus 2 cancel, leaves us with a final answer of x plus 1 over x plus 2. So that's question number 2. Number 3, factoring. Of course, the first step in factoring, look for that common number. And in this case, that number is x, common to both of them. We factor out the x, and we're left with the quantity x minus 2. Denominator is a difference of squares, but with the actual number first and the variable second. So notice how that factors the numbers first. So it's 2 plus x and 2 minus x. And at first blush, you might say, well, there's no canceling, there's no identical pairs. And that's correct. There are no identical pairs. But absolutely, x minus 2 and 2 minus x are equal. That is to say, they're signed opposites. Whatever number x minus 2 is, 2 minus x is the opposite signed number, right? Um, this x is positive, this x is negative. This 2 is negative, This 2 is positive. These two expressions are negatives of each other, is what we're saying, right? In general, if you have a minus b and b minus a, unless a and b are the same number, then those two are negatives of one another. Okay? So from there, we're going to get canceling, but we're going to get canceling with a factor of negative 1 left that I'll write in the numerator. And so final answer for number 3, x times the minus 1 gives us minus x over 2 plus x, or of course addition could be an x plus 2. So there's your final answer for question number 3, right? Because of the negative cancellation, that's a factor, a multiple of minus 1. So it's x times minus 1 in the numerator, which becomes negative x. So there's our answer to question number 3. Now, number 4, we're moving on to a sum situation. So we need a common denominator. To add fractions, you must have a common denominator. And in order to obtain that common denominator, it's sort of to your advantage to factor the denominator, at least the one on the left, and get a look at it. They have t in common. And so now, as you compare the two denominators between your two ratios, we have a denominator of t squared and a denominator of t times t plus 1. Well, if we want to make the denominators match up so that we can add, then this denominator on the left-hand side is missing a factor of t plus 1. What you do is you multiply top and bottom by that t plus 1 on that left-hand piece so that you're not changing the value of the fraction. And in doing that, 1 times t plus 1 is going to yield this t plus 1 right here. Now, on the right-hand side, as you compare the denominator, you're going to be missing a multiple of t. In order to get the t squared, you're going to need a multiple of t, which again, you do top and bottom. So you multiply the top by t. Now, in doing that, t times 1 produces a plus t. Now, we've produced a single fraction with a common denominator of t squared times t plus 1. In the numerator, if we add 1t and 1t, we get 2t plus the constant 1 over t squared times the quantity t plus 1. Final answer. Now, you could, if you want to, you could, if you'd like to, distribute that t squared in the denominator, but it's not really required. Okay, so there's the answers to questions number 1 through 4. We hope you found them helpful. And if you have any additional questions about any of these exercises, please either get to us through the portal on the WebAssign.net or send a direct email to cumath@clarkson.edu.